Shall I just kick off? Is everyone up for some Kubernetes talk? Is it, when the red light's on, is it muted or is it active? It's good. I'm here today to talk about Kubernetes, which is, as mentioned, from a kind of orchestration tool from Google. Has very little, if I'm honest, to do with JavaScript. But given that JavaScript can run on the server and you will have to at some point deal with deployments, etc., it may well come in handy for some of you. A little bit about myself. I'm Alex, a developer at Zazo. Some small confessions that my JavaScript is about as good as my Icelandic. And I have Vim skills of a CEO, so we have some live demo stuff coming on later. Hopefully it won't be too bad. So I'm going to go through these 4 things. Very briefly, I'm going to go over containers. Anyone here using containers or has touched anything with Docker or anything? Yeah, nice. Anyone here used Kubernetes at all or heard of it? Some hands, nice. And then I'll do a demo of Kubernetes and show you the awesomeness of deployments. Some context for why I'm even here talking about this is Christian Kodsen was trying to get me to give a talk for a while now. And I found out about Kubernetes this summer and absolutely fell in love, if you can fall in love, with a orchestration tool. And I have been trying to tell everybody about it. So this was a good opportunity for me to come down. So we're going to start off talking about containers, Docker and Rocket, you may have heard of. Very briefly, just so you understand what Kubernetes is working with, we have to know about containers. So a container is a way that you can define your application, all of its dependencies. Not just if you're in JavaScript land, you're kind of package.json, but also all of the underlying dependencies from the operating system up that are required to run your application. And what happens is you package that all up into quite a large kind of 400 megabyte file, and that thing is the thing that gets shipped to servers that can be deployed and run really quickly. You define what ports are exposed, and the ultimately what's great about Docker when it came along was it was finally a larger group of people agreeing on a format that we could all use to deploy stuff. So this is an example of a Docker file. You don't have to know too much what it does, but this is Elasticsearch. I've cut a few lines out, but roughly this is the length of the file. And if you have Docker running, you can just do kind of a Docker start of this thing, Docker run, and you would have Elasticsearch running locally on your machine. And what this means is that it's a great tool if you're in the position of moving from a monolith to a microservices kind of architecture, or if you're starting fresh and want to kind of get something working straight away. What happened before, at least in my experience before Docker, was building lots of tooling around how to do deployments. And if you wanted to go for the microservices approach, you'd either have to come up with your own internal standards for how things should look and how they can be deployed, or everything would just be very different. And if you moved companies, you'd have to learn all of their stuff. What Docker and the container format, the open container format, gives us is a standard which we can all just write these kind of Docker images for, and then just give them to the ops guys, or if we're in DevOps kind of culture, just deploy them ourselves. And it just means there's less needing to learn new stuff, which is a good thing. The problem with going to the microservices world is that you soon hit a lot of problems. How can I make sure I have the right things deployed? How can all the containers I've got, all these different layers, actually find each other, given that I'm always swapping stuff out, creating new IP addresses and all the rest? And you soon kind of get to this despair point of, was all this mess worth it? Give me back my monolith. And that's where Kubernetes comes in. It's one of the many ways to solve this problem. It's not the only by any means. If you Google kind of the Docker ecosystem, you'll find thousands or hundreds of different projects doing similar things. But this is an open source equivalent of what Google use in-house, Borg, I think that thing is called. And they've been running everything on containers long before Docker came along. So if you imagine you're just treating your server farm as just a pool of resources, and you have all of your applications, you just want them to be run somewhere, you don't care where they run. This is what Kubernetes and Borg does. So this is the basic architecture of Kubernetes. You have a master, and that's where all your API requests go to, and you have each one of these nodes as a server. And if you need more capacity, you want to create new services to run, you can just add more nodes to the cluster, and it just scales linearly in that way. The key components are pods, replication controllers, and services. And I'm going to very briefly go through them, and then we'll go to a nice live demo. So a pod is a grouping of one or more container that you want to be deployed together wherever it goes. So an example might be your web application is one container, and then maybe you have some sort of logging, shipping off to Sentry or whatever you might be using. I've never actually used two containers in a pod, but it's a possibility. And the two containers share everything in terms of network space. So you can contact the other container on localhost. You don't have to worry about service discovery. And each container has this idea of a liveness probe. So on each one of these nodes is a kind of the kubelet, it's called, is running. And it's doing all sorts of things for you, communicating to the master, making sure that what you're telling it to happen happens. But it also is checking, are all the containers running on me live? And if they're not, it will just kill it off. It will get rid of that container. And each pod also has labels that you can change, and it's a really powerful way of dynamically doing service discovery. So then you have the replication controllers, and what they're responsible for is making sure that the number of nodes of a certain type of pod, you tell a replication controller, I want 2 of my application to be running at any time. And its job is just to make sure there are always 2. If you create another one, it will delete it. If you delete one, it will create one. And that's what their job is. And that's why the liveness probe works, because what happens is your container dies, or it looks like it's dead, so the kubelet kills it off, and the replication controller goes, oh, there's one missing, and creates another one. And these are really, their main power comes in, one of their main strengths is in rolling updates. And I'll give you an example of that later. So you can just roll out a new version of your service with 0 downtime straight out of the box. Services, they solve the problem of how can each layer of our application find each other? How do they know where they are in the world? And what a service does, it targets this dynamic label that I was describing earlier, and you basically say anything with like the label of app is front end is the front end service, and then that is always available on a certain IP address, and it's kind of round robin routed. And the same can happen with your database. I'll give you an example of the database in a second. So rather than having to care about the container underlying the holding the data, you can just route to. You get your app to just talk to DB service, in my case, and it will just find it through the service that's exposing it. And yeah, and this is all magically exposed to the containers in the cluster, as you'll see shortly. And finally, there's this scheduler which Kubernetes uses to pick which node to run your pod on. This is really good for, you also label your nodes, so you can label a node as like this has SSD on it, and if you want your database to only be run on a node with SSD, you can dictate that when you're getting it kicked off, and your scheduler takes all of this kind of stuff into account, as well as kind of resource usage and what node's using the least memory and all the rest. But all of this just comes for free. So I'm now going to give you a quick demo of a application I made for this called KubeShark. Kubernetes and sharks, what can go wrong? So I'm just going to show you, what I've got running on Google Container Engine, which is like it's actually hosted Kubernetes, basically. I recommend, if you want to play with it, you can get a 3-month free trial, which I'm using at the moment. And I can zoom in for sure. And so if I just see what's going on in the world, I can just ask for get services, for example. And here we have the KubeShark service running on this IP address. And I can get this IP address if I just show you that I'm actually cheating a little bit here. So kubeshark.com, don't go to it, doesn't exist, but it does on my machine. So I'm just going to go over to kubeshark.com, and this is kubeshark.com running in Google Container Engine. And I can also go and get the replication controllers, which I was talking about earlier. You see there's one, it's running CubeShark version 0.4 there. And I don't know whether this is big enough still. So I get LC again. And it's running 0.4 and it has these kind of selectors. That's how you can actually select that replication controller. And finally I can go and get all the pods. And I'll get them by label. If I ask for app equals API, I think. This gets the two, I have two running pods running my application. If I get all of them, I'll see also a Postgres machine running. And that is the state of things. So I have one service running, I have one replication controller that's holding on to these two pods. And what I can do is, I'm just going to show you something that I can actually go in. If you've not used Docker, this will just seem like kind of random magic, but I can actually run commands on these pods. So I can just ask it to run a bash shell, and now I'm actually running commands on that machine itself. And if I just ping here db service, I'll see it has unknown host because I've not created a service. And I'm just going to show you the awesomeness of the kind of service discovery stuff. So if I just exit this guy. And do a kubectl create -f of. So what I'm doing here is I'm talking to that API and I'm saying, here is some declarative stuff I want to happen. You just sort out how it happens. What I'm actually asking for here, if I show you this file, is a service to be created. It's going to be called db service, and down here in the selector in the spec, that's saying any container, any pod that's called Postgres, that's going to be your guy. And so that's now happened, and this is definitely blocking your view. And so what I can do now is go back into the bash, and you'll see that actually now, if I just do ping of db service, it now resolves to an IP address. So that's just happened magically without me doing anything other than just telling it, sort your life out with Kubernetes. The final thing I want to quickly show you before we go on to the next part, if I load the logs, I can tail the logs of what's going on the servers, on the two containers, and I can just refresh this page here and I'll show you that it's just load balancing each request to the server across the container set. And that's just all happening again for free. I haven't looked, I actually think in reality I wouldn't want this. I think I'd actually want to kind of bind my client IP to one, but I haven't looked into how you can do that yet. I'm assuming it's possible. But yes, so that is kind of the rough idea of what Kubernetes can do. And with those powers come some awesomeness rather than responsibility. So what I'm going to do quickly is talk about deployments, if my screen will Jenkins, and just if you actually want to go straight into continuous deployment, this is actually very much a possibility.
Does it wait for the connection to close, or do you just have to put a timeout on the rolling update?
Which connection, sorry?
Like all the incoming connections
to
the machine, does it wait for them to close, or does it just kill them off? And
I'm not sure. I mean, at least when I've been refreshing manually, I've never had it do anything crazy. But I've not had like WebSockets open or anything, so I don't know what it's going to do. But what I'm going to do is I'm going to run this, and at the same time I'm going to go over to this split screen here, and we're going to watch what's happening. And you'll see that actually it's going to create the top here. I'm showing pods on both.
Does it stop the rolling update if the new version fails?
Sorry, who asked the question? I can't see. There it was. Yeah. The question was, does it stop the rolling update if the new version fails? The answer is, I don't know. I don't think it would stop it. I think that it would. The new version would be live, but you would have lots of problems. So what you want is that you actually want to do a canary deploy, and you want to have you actually probably want to do some more manual steps than this, and have your second replication controller only deploy one, add it to the service, check that it's all working, and then go for the full scale. Let's get this guy in. So I think the actual rolling update won't do anything clever about that. So yeah, here we have on the bottom the replication controller. At the top we have the two pods, and I'm just going to go ahead and run this guy, and we'll see stuff happen. So now underneath we have the second replication controller with the crazy name. It's been created. It has one replica. That replica has been created, the pod, and it's just going to take a few seconds for it to. It goes through each step slowly. So that's now ready, so it should now delete one of the old nodes. There it goes, and then this is updated down here. And I'm sure you'll take my word for it. This is all going to happen. So while that's going on, this is a shiny view of the world that I can show you as well. The semi-shiny. I mean, it shows you exactly what you get on the console. So if you have some sort of someone who's not very good at Vim, for example, they might prefer this. Sure. It says I'm screen sharing. Yep. And if I go back to this now, it's now fully deployed, and I can just refresh this page, and you'll see a new version of the CubeShark appear once it actually finishes downloading images. There's a pretty mammoth picture of the sea appearing. It's about as big as the ocean. And it's about to get there. So as you can see, my whole compression stuff is not great either. Finally, if I go back to the thing, yeah, that's everything I had to show. Here's some credits and references. I'm going to put the slides on Speaker Deck straight after. So if you want to read up about any of this stuff, feel free. That's me done.
Maybe it exists, but it's kind of the community aspect. Like, as for example, the Docker has, the Docker Hub, and which saves you a lot of time and a lot of effort, where you basically just download Docker files, generate whatever you want, and you want to assemble different Docker files, generate, your node as you wish. Does this have some kind of an
So the question was in relation to Docker Hub and other Docker images, can they be used? I guess the answer is absolutely. Your image can come from anywhere. Mine are coming from. I'm pushing my CubeShark images up to the Google registry, which is similar to Docker Hub, but you can also pull them down from Docker Hub, so you can run. Oh yeah, and it'll just run Docker images for you. It's very highly. It's like a first-class citizen to the network.
I was trying to understand the concept of the Kubernetes cluster.